All right, welcome to lesson 2, which is factoring polynomials, part 1. Before we get started with this, I do just want to cover something real quick. So I'm going to go to this other tab and then I'll hop back over there. So what is factoring? Now this is something that we've talked about in previous math classes, but it is important we all have the same understanding moving forward. So factoring is just writing an expression as the product, so think multiplication, so we're multiplying the product of its prime factors, okay? So a prime number is a number that has no factors besides itself and 1. So 3 is a prime number, 7 is a prime number, 13 is a prime number, and on and on and on. All right, so let's do one example where we factor an integer before we go back to factoring polynomials. So if we want to factor 20, well that's equal to, I know that's equal to 2 times 10. However, 10 is not prime, so I got to keep going. So 2 times, well, I can rewrite 10 as 2 times 5. And by writing it as 2 times 5, I've written 20 as the product of its prime factors. So 2, 2, and 5 are all prime. All right, so that's my goal here. And we can do another quick one. Let's say we want to factor, let's do 30. All right, so 30 is equal to 3 times 10, but again, we know 10 is not prime, so we got to keep going. So 3 times 2 times 5, since 10 is 2 times 5. So this would be called the prime factorization of 30. All right, so we're going to be doing the same exact thing, but with polynomials. Now, sometimes you'll have 3 factors, sometimes you'll have 2 factors, sometimes you'll even have no factors, right? So if we were going to factor 13, well, we can only write that as 1 times 13. So really, we can't write it as the prime factorization because it's already prime. All right, so let's go jump into factoring polynomials. So we want to keep in mind multiplying polynomials because multiplying and factoring very much go hand in hand. They are the opposite of one another. They're kind of similar to how multiplying and dividing are opposite, but multiplying and factoring, you actually see both of the factors or all of the factors. All right, so we know that when we're multiplying and we get something that looks like this, we get a quadratic trinomial. That probably came from, x plus something times x plus something, something of that form. And we also know that we can use the box method. So we're just going to go ahead and fill in everything that we know. We know that x squared has to come from x's. It can't come from integers because it's a variable term. And we also know that 15, which is our constant term, has to come from a number times a number. So we really know a lot about those two terms. All right, we know that we've got variable only and then constant only. So we don't know much about this 8x term because remember, when we were multiplying polynomials, that middle term came from 2 other terms. So this 8x might have been 1x and 7x, but it also might have been 3x and 5x or 4x and 4x. So we don't really know much about that 8x term. What we do know is that whatever was here plus whatever was here had to be 8x. And we also know that whatever's here times whatever's here has to give us 15. So really what we're trying to do is we're trying to multiply to 15 with the same numbers that we're trying to add to 8 or 8x. I'm just going to leave it 8 for now. So I want to write out all the factors of 15. So the different ways of getting 15 are 1 times 15 and 3 times 5. Those are the only possibilities. All right, now there's only one option here. 3 times 5, if I add those instead of multiplying them, that's the only way that I'm going to get 8. So 8 is equal to 3 plus 5. So these two factors are my golden numbers, right? 1 times 15, yes, it gives me 15, but 1 plus 15 does not give me 8. So what do I do with these numbers? Well, now I know how to break apart 8x. I know that 8x has to be broken apart as 3x, positive 3x, and positive 5x. Because that's the only combination that's going to give me 8x along my diagonal and 15 here. And now I factor, and this is just like working out a puzzle. So I'm basically trying to figure out, okay, what was here and what was here to give me these inside terms, and then same thing along the vertical side. Well, x squared, there's only one way to get x squared. That's got to be x and x, right? There's no other way to get x squared there. And then over here, well, if I know if this is x and this is 3x, then this must have been positive 3. And if this is 15, well, I'm thinking, okay, what times 3, since I already have this, gives me 15? Well, that has to be 5. And that also makes sense. Let's scoot that over. All right, well, that's supposed to be plus 5x. I don't know why it's getting cut off. All right, and that, no, it should just be plus 5. That's why. Plus 5, because 5 times x right here gives us 5x. All right, so we're almost done, not quite. Now we have to write the actual binomials. So one binomial is up here, x plus 3. And then the other binomial is right here, x plus 5. And I can check that these are correct by maybe using my other method, maybe using distributive property to multiply these together and make sure that I get the original. So really we're just undoing multiplication. So think of factoring as undoing multiplication. All right, so over here, I'm going to use a different method here. I'm going to use my reverse distributive property. So my reverse distributive property, I know I'm going to have some number or some term times something in parentheses. All right. Well, I want to think about what is common to both of these terms, 12x and 20. Well, a number that they both share is 4, and in fact that is the largest factor that they share, so we call that the GCF. So our GCF here equals 4. And so that's the number that's going to be out front. Now if they shared an x or an x squared, that would also be a part of the GCF, but they just share a 4. So I'm thinking, okay, what would I have to have multiplied 4 by to get 12x? Well, I'm just going to divide. 12x divided by 4 is 3x. And then same thing for my second term. What would I have to multiply 4 by to get 20? Well, that's 20 divided by 4, which is 5. So I've just undone my distributive property, and this is completely factored. So I just want to really quickly compare and contrast these first two examples. This one I got 2 binomials because I had a trinomial. This one, I only started with a binomial, so I couldn't have had 2 binomials multiplied by each other. I have to have a monomial times a binomial. All right, so next one is again a binomial, but this time it's quadratic. All right, and we're going to use the box method here. Now, if we only have 2 terms, we only need 2 boxes. All right, the only reason we needed 4 up here was because we knew that this middle term came from 2 smaller pieces being added together. All right, so number 3. All right, I went ahead and set this up ahead of time. So we've got 8x squared and negative 18x. All right, and we're thinking about, okay, same thing that we were up here. What's the GCF? What is the largest thing that these two have in common? Well, they're both even, so I know that they both have a factor of 2. But do they have anything larger than that? Well, 3 and 4 don't work. So I know that 2 is the largest GCF there with regard to the coefficients. And I see that this has an x squared and this has an x to the first. So the thing that they have in common is just 1x. So now I'm figuring out what goes up here. Well, if this is 2x, I want to focus on my coefficients first. 2 times what equals 8? 4. And then x times what gives me x squared? Well, I would need one more x. So 2x times 4x equals 8x squared. And then over here, all right, 2 times what equals negative 18? Well, that's negative 9. And x is already here, and I don't need extra, so just minus 9. And now, whoops. Now I can write this as 2x times 4x minus 9. Again, I don't necessarily have to have 2 binomials. I just have to break it apart as much as I can. All right, we're going to do one more strategy, and then you'll see I'm going to have you try a bunch on your own. So this is, I'm going to use factoring by grouping here, so different from the box method. We've done a couple with the box method. All right, this is going to be the opposite of the distributive property. So just like up here, I know that I wanted to multiply to that constant term. So I want to multiply to negative 36 here, and I want to add to that middle term, so positive 5. So same thing, I want to list out all of my factors, except I'm not super concerned about the negative right now. I just want to list out the factors of positive 36. So that would be 1 times 36, 2 times 18, 3 times 12, and 4 times 9. Those are all the factors of 36. So I want to think. I do need to multiply to negative 36, which means one of these is going to have to be negative. The only way to multiply to a negative number is by having one negative number times one positive number. With keeping that in mind, I also know that I want to add to a positive 5. So that means that whichever factor pair I choose, the bigger one has to be positive. Otherwise, I won't end up with a positive 5 when I add them together. So I'm going to quickly eliminate 1 times 36 and 2 times 18. They're just too far apart from each other, so if I add them, I'm not going to get 5. So 3 and 12. Well, I know that the larger one has to be positive. So if I made this negative, negative 3 times 12 is negative 36, that's still 9. That doesn't work. All right, so let me try making this 4 negative. Well, negative 4 times 9 is still negative 36. And if I do negative 4 plus 9, negative 4 plus 9 does equal 5. So, hold on. All right, we're back. So, hopefully. All right, so I know that negative 4 and positive 9 are my magic numbers here. And so I'm going to break apart this middle term the same way I did up here, just not using the box. So I'm going to have x squared, that hasn't changed, and instead of having plus 5x, I'm going to have negative 4x plus 9x. Now notice that negative 4x plus 9x is still equal to 5x, it just looks differently. And I have my minus 36 constant. All right, next I want to factor the GCF out of these first two terms, and then separately I'll do these second two terms. So think about when we multiplied, we had two separate sets of distribution. So here I know that x is what's common between x squared and 4x, and if I think about what the binomial had to have been, it must have been x minus 4. So we're just undoing that multiplication. We're doing reverse distributive property. And then same thing with those next two terms. What's common between positive 9x and negative 36? Well, they share a 9. And then I know that what's left over had to have been x minus 4. So this should look pretty similar because this is what our multiplication looked like in the last video. So now I want to think about what did that first binomial have to be. I can see that the second one is going to be x minus 4 because that's here and here. Well, if I take the other two pieces, which are x plus 9, and I write them in this factor, now I have my two binomials. So this is just an alternate method to the box method. You're welcome to find whichever one works best or use whichever one works best for you. All right, so you've got 5, 6, and 7 that I want you to do on your own. I want you to try a mix of the box method and the factoring by grouping. So go ahead, pause the video, give that a try, and come back when you're done. All right, welcome back. So let me give you some answers here. I'm just going to factor by grouping because it's easier. I don't need to make the box. So this middle term we wanted to split apart as negative 9x and negative 9x. Got our plus 81. I'm just going to jump to the final here. That should be x minus 9 times x minus 9. And you probably won't see it written like this. We can write it a little bit more succinctly as x minus 9 squared because we just have x minus 9 times itself. All right, over here we've got 3xy, that was the GCF, so if I'm using the reverse distributive property, I would need to multiply that by 2x to get 6x squared y plus 5 to get 15xy. So that's that. And then this one down here, if I've got x squared, I want to break apart that middle term as negative 7x and negative 8x. So those magic numbers would have been negative 7 and negative 8, because negative 7 times negative 8 is positive 56. And then we go ahead and we factor that as x minus 7 times x minus 8. So by now you might be noticing that whatever those magic numbers are are just going to be the second term in your factors. So here our magic numbers were -4 and 9. We had x minus 4 and x plus 9. Here those magic numbers were 3 and 5. We had x plus 3 and x plus 5. That only works when we have an x squared. So you'll notice that in all of those examples, you didn't have a coefficient of the x squared. We just had one x. Well, we did have a coefficient, but it wasn't anything other than 1. All right, so number 8, the first thing that we want to do here, and this is something we'll see more of moving forward, is we have all even terms or coefficients here. So what we need to do first is factor out that GCF. So if right off the bat we can tell that there is a number that is a factor of each of our terms, we take it out. So if we factor out that 2, I'm using reverse distributive property here, that leaves us with x squared plus 2x minus 15. And again, that only works because they're all even. If they were all multiples of 3, then I would factor out a 3. All right, so this is my new starting point. All right, so I'm keeping the 2 here, but I'm ignoring it for right now because it's already factored out. So I need to multiply to -15. So I'm going to list my factors are 1 times 15 and 3 times 5. But I know that I'm also adding to 2. So again, since this 2 is positive, that means that, well, I know it's not going to be 1 times 15 because that's way, way, way too big. 1 plus 15, or even if one of those was negative, is not going to give me 2. So I want to figure out what combination of 3 and 5, which one of those has to be negative in order for me to get 2. Well, the smaller number has to be negative. Whoops. -3 and then +5. So if I do -3 plus 5, that does give me 2. All right, so I'm going to use my factor by grouping here. So I still have that 2. That 2 has to stay with me the whole time. And now I'm just going to break apart that 2x right here as -3x plus 5x, and then I have my minus 15. And I'm going to keep going. Oops, hold on. I'm going to keep going. So again, that 2 is still out there. And now inside this group, so right starting here, I know that x is the GCF between these two terms. So I have my x taken out. Then I have another set of parentheses, which is a little, cluttered there, but that's all right, times x minus 3. And then I'm taking out my GCF of 5, and that's also going to be times x minus 3. So hopefully we're noticing that we should be getting the same two binomials here, because otherwise our multiplication problem would be all messed up. Still have my 2. I know that one of my factors is x minus 3, that's right here and right here, and then my other one is x plus 5. So in this case, I do have 3 factors. One of them is a monomial, so 2 is a monomial, and then these other 2 factors are binomials. All right, I want you to reference number 8 when you come down to do number 11. All right, you'll notice that 3, 15, and 108 are all multiples of 3, so you should be able to take out a GCF like we did right here. All right, looking at number 9, all right, we have something that looks a little funky. We have an x squared term and we have a constant term, but no x term. So I want to rewrite that so I can see 0 x's. I still want to be able to see what that middle coefficient would be. All right, so I know that I'm multiplying to -25 and adding to 0. Well, the only option there, they have to be equal and opposite. So that is going to be -5 times 5, and I know that -5 plus 5 does in fact equal 0. So I can actually jump, just give some space, I can actually jump straight to x plus 5 times x minus 5. Hopefully by now you're getting the hang of it and we're not necessarily needing to write out this middle step every single time. All right, go ahead, pause the video, give number 10 and 11 a try. I'll give you some answers when you come back. We'll talk about number 12, and then you'll have your reflection question, and then down here. All right, so go ahead and pause. All right, welcome back. So number 10, our GCF was 5x times x squared plus 4. Now, this does look like, oh, I forgot to mention something. Hold on, let me go back to this one real quick. So sorry. This right here has a special name. It's called the difference of perfect squares because x squared is a perfect square. We know that from our radicals unit. And 25 is also a perfect square. And difference means subtraction. So this right here, we're subtracting two perfect squares. That's a special name for that polynomial. Over here, we have the sum of perfect squares, but that's not as helpful because in order for us to be able to factor, we would need to have a minus sign. So the only way that that middle term cancels out is if you have one positive and one negative. All right, here you would either need two positives or two negatives, which doesn't allow us to factor any further. If this were a minus 4, you would be able to factor it just like we did with this one over here, but it's not. Sorry about that. All right. Number 11, I'm going to write it in pink, I guess. We should factor out I guess not. Factor out a 3, and then you're left with x squared plus 5x minus 36. And then after that, we've got 3 times x minus 4 times x plus 9. One thing I didn't mention is it does not matter what order these factors are in. So it could be x plus 9 and then x minus 4. The 3 is always in front just because that's an integer. But if you have these two backwards, that's totally fine. All right, last one, and then we'll get you out of here. So in this example, we're trying to multiply to 7, and we're trying to add to negative 3. The only factors of 7, because it's prime, are 1 times 7. And I guess another way to multiply to positive 7 could be negative 7 times negative 1. However, either one of those, either 1 and 7 or negative 1 and negative 7, are not going to add to negative 3. There's just no way to force those to add to negative 3. So we're kind of in a bind here. We can't factor it, right? We have to use integers, but the integers that we are looking at don't really work together. All right, so what we call this polynomial, what we call this right here, is a prime polynomial. All right, so that is when you can't factor the polynomial. All right. So you will see examples of that where you can't factor it and you just have to call it prime, and that's fine. All right, so go ahead. You're going to answer this question about Sally, complete sentences, and then remember, in order to get full credit, you need to finish these two sentences. All right, we will not do lesson 3 in this video. We'll do that next.